In logic and mathematics, a truth value, sometimes called the logical value, is a value indicating the relation of a proposition to truth. Classical logic. In classical logic, with its intended semantics, the truth values are true and untrue or false, that is, classical logic is a two-valued logic. This set of two values is also called the Boolean domain. Corresponding semantics of logical connectives are truth functions, whose values are expressed in the form of truth tables. Logical biconditional becomes the equality binary relation, and negation becomes a bijection which permutes true and false. Conjunction and disjunction are dual with respect to negation, which is expressed by De Morgan's laws. PQ propositional variables became variables in a Boolean domain. Assigning values for propositional variables is referred to as valuation. Intuitionistic and constructive logic. In intuitionistic logic, and more generally, constructive mathematics, statements are assigned a truth value only if they can be given a constructive proof. It starts with a set of axioms, and a statement is true if you can build a proof of the statement from those axioms. A statement is false if you can deduce a contradiction from it. This leaves open the possibility of statements that have not yet been assigned a truth value. Unproved statements in intuitionistic logic are not given an intermediate truth value. Indeed, you can prove that they have no third truth value. A result dating back to Glavenko in 1928. Instead, statements simply remain of unknown truth value, until they are either proved or disproved. There are various ways of interpreting intuitionistic logic, including the Brouwer-Hating-Kolmogorov interpretation. See also, intuitionistic logic, semantics, multi-valued logic. Multi-valued logics allow for more than two truth values, possibly containing some internal structure. For example, on the unit interval 0, 1, such structure is a total order. This may be expressed as existence of various degrees of truth. Algebraic semantics. Not all logical systems are truth valuational in the sense that logical connectives may be interpreted as truth functions. For example, intuitionistic logic lacks a complete set of truth values because its semantics, the Brouwer-Hating-Kolmogorov interpretation, is specified in terms of provability conditions, and not directly in terms of the necessary truth of formulae. But even non-truth valuational logics can associate values with logical formulae, as is done in algebraic semantics. The algebraic semantics of intuitionistic logic is given in terms of Hating algebras, compared to Boolean algebra semantics of classical propositional calculus. In other theories, intuitionistic type theory uses types in the place of truth values. Topist theory uses truth values in a special sense. The truth values of a topist are the global elements of the subobject classifier. Having truth values in this sense does not make a logic truth valuational.